In this lesson, we are graphing linear inequalities, but before we do that, we're going to review some inequality basics. First, the inequality symbols themselves. There are 4 different symbols for inequalities. There's less than, there's less than or equal to, which is just the less than sign with a bar underneath it. Now, these two make an L. When you hold up your 2 fingers in your left hand, they make an L for less than, so hopefully that can help you remember those. Now, greater than faces the opposite direction, and greater than or equal to is just the greater than symbol with the bar underneath. Now, when you are graphing inequalities, so just your basic inequalities, when you graph them, you have your inequality that tells you some different things about what that graph of that number line is going to look like. So first of all, you either have an open dot or you have a solid dot. Okay, so the open dot is going to occur when you have less than or greater than without the bar underneath. Okay, so that's just the less than or greater than. The solid dot occurs when you have the less than or greater than symbol with the bar underneath. So the solid dot occurs when you have your symbol with the line underneath for equal to. Then it also tells you which direction to shade. So you shade below for everything that's less than. So less than or equal to. You shade below or to the left. Now you shade above if it's greater than or equal to. Now let's do some examples. Just some real basic examples. All right, first let's do number 1, x is less than 5. So if x is less than 5, that means that your number on the number line must be less than 5. So what are some numbers on this number line that are less than 5? Well, 1 is less than 5, 2 is less than 5, 3 is less than 5, 4 is less than 5, 5 itself is not less than 5. So that's going to be an open dot. Notice that this does not have the line underneath it. So that's going to tell us an open dot. Now the direction that we shade is where all of those numbers that are less than 5 are located, which is everything to the left or below the number 5. So we're going to shade everything to the left. Now let's do number 2. X is less than or equal to -3. Well, what are some numbers on this number line that are less than or equal to -3? Well, remember that less than means everything to the left of it. So -5 is less than -3. -4 is less than -3. And -3 is less than or equal to, so that equal to, that bar underneath, means that -3 is included in this graph. Now, we are still shading everything to the left because all of these numbers occur to the left of the number -3. Now we have x is greater than -2. So where is -2 on this number line? And is that going to be an open dot or a closed dot? So since this does not have the bar underneath, that's going to be an open circle, an open dot. Now all the numbers that are greater than -2 would be -1, 0, 1, 2, and so on. So we're going to shade everything to the right. Now we have x is greater than or equal to +4. So where's +4 on this graph? Okay, and since that has the bar underneath, that's going to be a closed dot on +4. So if x is greater than or equal to 4, that's going to be 5, 6, 7, 8, and so on. So everything to the right. So this was just a basic review of your inequalities. Now let's graph some linear inequalities. When you're graphing a linear inequality, it's going to look like a linear function. The only difference is that it's going to have an inequality symbol instead of an equal sign. So step 1 is just to graph the inequality in Desmos. Step 2 is to determine if the line is solid or if it's dashed. If the line is solid, so if you graph your line and let's say it looks like this and it's solid, that means every point on that line is a solution to that inequality. If your line is dashed, so if your line looks like this when you graph it in Desmos, then that means the points on the line are not included in the solution. Step 3. Is your graph shaded above or shaded below? If your graph looks like this and it's shaded above, then those shaded regions, all those points in that shaded region, those are all solutions. If your line is shaded below, like this, then all the points below the line are solutions. Now let's do an example and put those 3 steps into practice. Okay, so step 1 is to graph the inequality in Desmos. So in Desmos, I'm going to just type 2x minus 3y is less than 12. So when I type that in, instead of an equal sign, I'm going to use the inequality symbols. So you can see to the bottom left of the keyboard, you see the less than, greater than symbols. So we have 2x minus 3y is less than 12. Now look, Desmos does all of that hard work for us. I'm just going to sketch this graph on this coordinate plane. Since this line is dashed, points on the line are not solutions. So since the shaded region is above the line, all points above the line are solutions. So let's test out some solutions. So if I pick a point that's in this shaded area, it is a solution. So if I pick the origin, the point 0, 0, that's in the shaded area, so that is a solution. This is just an example. There are an infinite number of answers you could give. I could pick the point, let's say 1, 2, 3, 1, 2, 3, 4. The point 3, 4 is a solution. So we had 0, 0. Now we have 3, 4. And let's see, we have the point negative, let's do negative 1, 2, 3, 4, 5, negative 2. Negative 5, negative 2 is a solution. So they're just 3 examples of some solutions that are in this shaded area. Now, is 0, negative 4 a solution, and why? Why or why not? So when I look in Desmos, to be precise, I want to see the point 0, negative 4. If that point wasn't already there for us, we could type in our parentheses and then 0, 4, and it would graph, negative 4, excuse me, and it would graph that point for us, and we could label it if we want to. So now that point, is it a solution? Why or why not? So I'm going to give you 2 reasons. Reason number 1, that it is not a solution, is because it is on the dotted line. And if it's on the dotted line, then it is not a solution. If this were a solid line, it would be a solution. Okay, so now here's another reason why it's not a solution. If I plug in x equals 0 and y equals negative 4 into that equation, I'm going to get a false statement. Okay, so if I plug in to this equation, 2 times 0 minus 3 times negative 4 is less than 12, that's going to give me a false statement. okay, because 2 times 0 minus 3 times negative 4 is equal to 12. And 12 is not less than 12. 12 is equal to 12. So this is a false statement. 12 is less than 12 is false. So it is not a solution. Now let's do some practice questions. Number 1, graph the inequality. So first, graph it in Desmos. Y is greater than or equal to 3x plus 2. Right, okay. Now we are going to answer the question, which of the following are solutions to the inequality? So really all we have to do is go into Desmos and type those points and see which of those points fall in the shaded region or on the solid line. I've given each of these labels so that we can see which points are which. 4, 5, 6. That definitely falls in the shaded region. Okay, so we can check that one off because it does fall in the shaded region. B, 5, negative 3, that is not in the shaded region, so that is not a solution. 0, 2 falls on the line. So 0, 2 is on the line, and since it's a solid line, it is a solution. Then 1, 5 also falls on the solid line, so it is a solution. If this were a dotted line, those two would not be solutions. All right, let's look at number 2. We're going to graph this inequality, so I'm going to X out everything in Desmos so far, just so that we don't get confused. And we're going to type in this inequality. Okay, notice that this one is dashed. All right, let's test the point 0, 6. So is 0, 6 a solution? Why or why not? So the point 0, 6, if I type that into Desmos to see exactly where it is, let's see, that's this point here. Since that point is on the dashed line, it is not a solution. Now, if you wanted to test it out to be extra sure, what you can do is plug in 0 for x and 6 for y and see if you get a true or false statement. So when we do that, we have negative 2 times 0 plus 6 is less than 6. So negative 2 times 0 plus 6. So I'm going to type that into Desmos. Or you could do that by hand if you wanted. But you get 6 is less than 6. Okay? That is false. 6 is not less than 6. 6 is equal to 6. So this is not a solution. Okay, here is some more practice. Is the point 2, 4 a solution to the inequality? Well, let's see. We can graph this in Desmos. And then plot the point 2, 4. I'm going to label that. So since this is in the shaded region, that is a solution. Now, if we test this by plugging in x equals 2 and y equals 4 into this equation of sorts, this inequality, we will get a true statement. Okay, so 7 times 2, that's 14, minus 20 is less than or equal to 35. All right, so 14 minus 20 is negative 6. And negative 6 is less than or equal to 35. It is less than 35, so that is true. Okay, number 4, is the point negative 3, 1 a solution to the inequality? Well, let's see. Negative 3x plus 2y in Desmos is greater than or equal to 7. All right, and then let's test that point, -3, 1. Okay, that is in the shaded region. So since it's in the shaded region, it is a solution. Now let's test it. So that would be 9, positive 9, plus 2 is greater than or equal to 7. And 9 plus 2 is 11. And 11 is greater than 7, so that is true. Right, and number 5, for this one we will just use Desmos. We're going to test each one of these points to see which ones are solutions to the inequality. So we're going to type in for y is greater than 2x plus 12. All right, and with this one we get a dashed line. So be careful with a dashed line. Points on the line are not solutions. So we have to be careful about that. All right, so let's type in our 4 points and see which ones are in the shaded region. So let's look at our graph here. All right, so 6, 9 is in the shaded region. So yes, that is a solution. B, 5, 10 is in the shaded region. So that is a solution. -1, 1 is not in the shaded region, so that is not a solution. And 7, 4 is also not in the shaded region, so it is not a solution.